So welcome to this lecture on PWM and serial monitor. PWM, its full form is Pulse Width Modulation. Let us try to understand what we mean by PWM. Now, digital output pins. In the last class, we have discussed on the digital output pins. We have seen either pin 13 or 12 in the Arduino board we have used as digital output pins, and from that pin, according to our wish, we have programmed that pin will get either 5 volt or 0 volt. Okay, so either on or off of the LED we have controlled that. Another one is if we want to give a particular pin instead of on-off kind, that means either 0 or 5, rather we want all the possible values of voltages between 0 to 5 that as an output from a particular pin, then that is a kind of analog output pins. Okay, so this particular features are there in few pins in the Arduino board. Those are called pulse width modulation pins. In digital pins, what we have already observed that either low or high. Low indicates what? Low indicates 0 volt, and high indicates what? High indicates 5 volt. Basically, instead of low in the program or high in the program, we can also write 0 and 1. They are also means the same thing. Okay, and 0 or the low means basically the 0 volt is the voltage given in the pin. 5 volt, that is corresponding to the high. So this is kind of a digital, you can easily understand, and by this we have controlled the pin number 12 or 13 in the last LED blinking example that we have seen. Now, corresponding to 0 volt, LED position was off, and corresponding to 5 volt, it was on with the full brightness that we have seen. Now, in case of PWM pin, I am telling you that from 0 to 1, that means from low to high, that means from 0 volt to 5 volt, all the voltages can be varied. That means in case of a PWM, it is basically numbered from 0 to 25. Okay, so basically it's a 8-bit space, where 8-bit space means how many numbers can be written? You know, 2 to the power 8. 2 to the power 8 is what? 2 to the power 8 is 256. So 0 to 255, total 256 different values can be allotted here. So the whole voltages from 0 volt to 5 volt can be divided into 256 different numbers from 0 to 255. So instead of 0 and 1, here basically 0 and 255, that is what is the range. So what is the 0 corresponds to? 0 corresponding to 0 volt. That means when that pin will get a 0 volt, and 255 which is corresponding to 5 volt here, right? The corresponding to high, and all the intermediate values you can see here from 0 to 5 volt can be achieved by giving a intermediate value. Like you can give 100 instead of 255, then you will be somewhere in between. Okay, so in this way any values from 0 to 255 we can give, and accordingly we will get the voltage. Okay, so this is what is the mapping that we have observed. Now this 0 is corresponding to 0% duty cycle, and 5 volt which is corresponding to 100% duty cycle. So I know that you are a bit confused about what we actually mean by duty cycle. Duty cycle means basically that what percentage of time the supply is giving 5 volt. See, actually it is not an analog, actually it is digital, always in the form of a pulse. Okay, so pulse width is basically the time for which it is giving 5 volt supply. Okay, so the idea will be clear in the next. I will show one video, so from that video you will get an idea about what we mean by the duty cycle. So 0% duty cycle means, at least you can understand, this is corresponding to the off position of the LED, right? And 100% means on with the full brightness. And as we move from 0 to 255, gradually the voltage output from that pin will gradually increase. Okay, so somewhere in between 50% duty cycle, you will get a medium kind of brightness of the LED. So let us try to understand then what we mean by the duty cycle.
PWM stands for Pulse Width Modulation, and it consists of producing a square wave which you can control the up or high time. In a PWM signal, the minimum and maximum voltage are the values that limit the wave's oscillation. The space between them is called amplitude. A cycle is the interval of the wave where you can find one full repetition. The time a cycle takes to finish is called period, and the frequency is 1 over period, which gives you how many cycles are in a time unit, usually a second. A very important concept in PWM is the duty cycle. The duty cycle represents how much of the period in which the signal is high. In our wave, the signal here is high, and here is low. To calculate the duty cycle, you need to know how much of the period the signal is high. Let us set our high time as 6 milliseconds, our downtime as 4 milliseconds, and our period as 10. Now, let's use a simple rule to calculate the percentage of the period in which the signal is high. 6 relates to 10 the same way as our variable in percentage relates to 100%. If you solve this, you'll see that you get 60%, meaning that the signal is high 60% of the time. Let's imagine a PWM signal that oscillates between 0 and 5 volts. Let's say this signal has a duty cycle of 50%. Something interesting will happen to the output voltage. Instead of being 5 volts as expected, it will now be 2.5 volts. Simply putting it, this is because in a PWM signal you multiply the max voltage by the duty cycle. This is the formula. By applying this to our situation, you will see we will reach a 2.5 volts. Let's see what happens to the different components of the wave when I increase the duty cycle. As you can see, when I increase the duty cycle, the output voltage also increases. And when I decrease the duty cycle, the output voltage also decreases. Keep in mind that the output voltage can only oscillate between the minimum and the maximum of the PWM signal.
So I think you have got an idea about what is the duty cycle, and here you can see you can change this width. This is what is the pulse frequency that is coming, and this is what is the width, and width of this pulse we can change as you change the duty cycle. Here you can see the voltage is 5 volts for 50% of the time, and the 50% of the time it is 0 volt. So the net effect in this way ultimately will be 2.5 volt output supply. Now if the pulse width, if you reduce the pulse width, that means if you reduce the duty cycle, then what will happen, that your net voltage going to that pin will also reduce. And if you increase the percentage, that means if you increase the duty cycle, that means more time it will be at the 5 volt within a particular period, and smaller time it will be in the 0 volt. And that is why the net average, if you average out, you will find that it will be maybe close to 5 volt. So this thing is what we mean by duty cycle. So here you can see, here in case of a 92% duty cycle, you see the pulse width is very large, the width is very large. That means for a 92% of the time it is giving 5 volt, and only 8% of time it is giving 0 volt. Whereas you see for a 100% duty cycle, all the time it is giving the 5 volt. Okay, and you can see as you decrease the voltage, as you decrease the duty cycle, you see the smaller time, 23% time is only given 5 volt, and the remaining most of the time in a single time period is 0 volt supplied. And that is why if you multiply the total value, that means 5 minus 0, that is 5 volt, into the duty cycle, then you will get what is the actual volt that is given to that pin. So now let us make an LED indicator that will glow gradually and dim gradually in a periodic manner. Okay, So let us try to solve it in practice, in a simulation environment definitely. So this is our simulation Tinkercad simulation interface. In the last class we have done this one demo digital output pin. Now what we are going to do, another one, but now instead of only on off, like instead of only digital output, we want to give analog kind of an output, so that it will gradually glow and then gradually dim. Okay, this kind of problem we want to solve. So first what we do, we duplicate the same thing, so that we do not want to do the same thing. So duplicate, click on the setting and then click on the duplicate. Okay, so it has been copied. So first thing is that it changed the name. Click on this automatically generated name and give name demo PWM and serial monitor SN. Okay, so this is the name. Now here you can see this is our previous project. Go to the coding portion and you see this was our previous problem. Now what we want to do, we want to use a PWM pin. Already you know that there are certain pins having this particular symbol are called the PWM pins. Here you can see PWM symbol is like this. So 12 is not a PWM pin. So what we are doing, only we are changing this. We are just sending to 11 because 11 is a PWM pin. So only thing in the hardware circuit that we have changed is we have connect this LED to the pin number 11 instead of 12. So the corresponding change we have to do here also. So now it is green LED is now 11, the pin number 11. Now again you see the pin mode is output. So in the void setup we need not to make any change because 11 is ultimately giving some output. So LED is connected to output. Now we have to put this 11 the voltage so that it will gradually glow and gradually dim. So first write what is the problem that we want to solve. So control of LED dimmer, of LED brightness, control of LED brightness. Suppose this is the problem that we want to do, and let us formulate the problem that LED will be on, LED will be gradually glow, LED will glow gradually and then dim gradually, and the process will repeat. So this thing we want to do. So in this case, instead of a digital write, we have to consider a function which is not digital write, which is analog write. So we'll put analog write. But in case of a digital write, it was either high or low. But in case of analog write, we know what we have to put here. Any value from 0 to 255. We can put 100, we can put 255, which is corresponding to full glow, right? We can put 0, which corresponds to off. Clear? So what we want to do, we want to put some value, say that variable is brightness, okay, we want to put here brightness, and in a similar way here also we can put we'll take it later on. So we have put here brightness, but what is brightness? So you have to define this variable brightness. Let us consider a local variable instead of a global variable. Let us consider one local variable, brightness. So this brightness variable is an integer, so give its type. So integer brightness, initially let us consider the value of the brightness is 0. Okay. Now we want to vary this brightness from 0 to 255. Then the brightness of the LED will gradually glow from 0 to the full on, right? So for that we can change these brightness values from 0 to this using a for loop. Okay. So what is the statement syntax for the for loop? If for then give a bracket, and within the bracket you give the variable brightness is equal to 0 semicolon, brightness 0 to less than equal to 255. Okay, so from 0 to 255, and then we have to increment the brightness, and let us increment the brightness equal to brightness plus, say we are increment by 5. Okay, then bracket close, and this for loop will be within 2 brackets. You have to remember the for loop must be 1 bracket and another bracket you have to put that will close, and within these 2 second bracket you have to write all the arguments of the for loop. So in the for loop, brightness will start from 0 up to 255, and the increment in every loop is plus 5. Okay, now you see this brightness value will now initially will take 0, then it will go to the next line, then there is a delay. Give a very small amount of delay, not so high. Let us give a delay of 30 milliseconds. Let us give 30 millisecond delay. Then what will happen? It will again come here, and brightness value will be incremented by 5, and then it will check whether it is less than equal to 255 or not. If it is yes, then again go there, and now the brightness will be 5. So what will happen? Corresponding to 5, it will get certain voltage. So gradually what will happen? You will find that brightness will increase in this way, and in this way at a particular point you will find that the brightness will become 255. So in 255, then again it is true, it will go here and the brightness will be 255, then it will be full on, and again it will hold for 30 milliseconds. Then when it will go then it will find that this condition is not satisfying. Okay, so then it will come out of the loop. Okay, so what will happen then? It will come here, and what we want to dim it now, right? So for that, what we do is simply copy this portion. Now here you see the value of the brightness. Now for dimming, what we have to do? This is the glowing circuit, glowing part, and now we are writing the dimming part. This is the dimming. Now in this portion you see that brightness will be from 255 to it will be up to, it will be greater than equal to 0. Okay, and how it will change? Say brightness will be equal to brightness minus 5. Okay, now again the delay is this. These two lines are not required. These two lines you can delete. Okay, then now tell me what will happen, whether this is all right or not. So here you can see the brightness will gradually increase from 0 to 255, and if we do not give any delay, then it will not take any time for this increment. Okay, so that is why we have given a small amount of delay, so that will take certain time. Can you tell me how much time it will take to 0 to full on? Okay, 30 milliseconds in each loop, right? 30 milliseconds for each loop. How many loops it will run? You see, from 0 to 255, and in each step it is plus 5. That means if you divide 255 by 5, that number plus 1, because when initially it was 0, then also there was a loop that will take also 5 seconds. So this many numbers the loop will run, and number of times the loop will run multiplied by 30 milliseconds is the total time it will take for the complete glow. In a similar way, it will go in the downward direction from 255 to 0. But here you can see this 255 will be taken twice, because here it will end with 255 and the brightness value is 255, and then this 255 will be taken once again. So that you can avoid by considering it as 250. You can start from 250 here. Okay, then otherwise you will find there will be a delay, and similarly for the 0 also, the 0 will again come twice, as you can see. Okay, so anyway, let us run it and check whether it is doing accordingly or not. So start simulation. So here you can see gradually it is glowing and then the dimming. This option is offered. This option, whatever we want, that we are getting. But still it is not in complete control, because we have not done any calculations. We have just arbitrarily put these values like 5, 30 and all that. But if you really want a specific problem that you want to glow it in 5 seconds, then you have to make certain calculations, and accordingly you have to put this increment and you have to put this delay. So this can be controlled. Okay, so now this is the way by which we can use the pulse width modulation. Okay, pulse width modulation pin 11 that we have used for the analog output using analog write function. This is clear. Now suppose we want to display in the serial monitor the brightness values. We want to see what are the brightness values it is taking, right? So this is what is the serial monitor. Here you can see, if you click on the serial monitor, that serial monitor window will come up, and here you can see the values if you want to print it. So for that, you have in the setup you have to write one command, that is serial. Here you see this is capital S, serial dot begin. Okay, the serial dot begin, this is basically the rate at which the data will transfer into the computer. Okay, so that rate is 9600 bit per second. 9600 bit per second, you can approximately thought like 960 characters per second, so which is quite a high value, so this is sufficient. Now serial.begin, this is the setup function that you have to use. Then you can use the serial monitor print, or you can see the display. So what kind of display you want to see? Suppose you want to see what are the values of the brightness. So for that, what you do, you just write serial dot print. Now serial.print will continuously print the data horizontally along a single line, but we want to print it, suppose in every new line. So for that, print ln. Ln corresponds to new line. So serial.print ln, we want to print what? The brightness variable. Okay. So if you do this, then you can see that how the values of the brightness. Similarly, we can also see what are the brightness values decreasing gradually here. Okay. Now you just start simulation and see this simulator. Here in the simulator, you see the values are coming. Okay, now stop the simulation and check these values. Here you can see from 0 it has been started, then 5 increments occurred each and every step, then it goes to 255, and you see the 255 is repeating twice, and then it will go to go to 0, and you see the 0 is also repeating twice. So if you want to avoid it, then what change you have to make? Tell me. Instead of writing this as 255, you just write it as, or you just delete this. That means it is less than 255. It will start from 0, then it will start from 255, and it will go when it is greater than 0. Okay, I think this particular change will solve the problem. Let us see. Okay, now stop it and check. First you check that 0. Here you can see that 0 is not repeating. see that 255 is not repeating. So you can also see in a graphical form here, this symbol you can see. You just keep it on and start simulation, and you can see okay, stop simulation. So you can get an idea that from 0 to 255 gradually it is increasing, and then from 255 to 0 gradually it is decreasing. Okay, so in this way we can get either the text in the serial monitor or the graph in the serial monitor. So serial monitor is a kind of a display that you want to see that what is happening there. Okay, so I think you have understood what we mean by the PWM pins and how to use it. Now you see the practical problems. This is very important. That clue, I have basically given a clue that if you remember that problem that we have discussed in the last lecture, to control a valve indicator, where that indicator suppose will full glow in 5 seconds, and it will keep open for next 20 seconds like that. So in 5 seconds it will gradually go from 0 to 100% brightness. Okay, so in 5 seconds you have to manipulate accordingly. So what will be that increment, what will be the delay, that you have to decide such that one particular loop will take, or the complete loop for glowing will take only 5 seconds. So I will give assignment accordingly, so you have to do those programs of your own. But the basic idea I think you have got, that how to connect it and how to use PWM pins and serial monitor. Okay, so this was basically the objective of this lecture. So we have already seen the serial monitor basically displays the status of brightness in the serial monitor, that we have seen how to do that. So this much for the day, but one last thing that I am telling you. So in your assignment I am going to give you the project where you have to draw this circuit in the Tinkercad. You have to write this program, and the whole thing now you have to send to me, and for that you will get the link of your work from here. Here you can see one tab where it is written that share. You have to click here, and then you will get a link like invite people. If you click on it, then you can see you get a shareable link. So what you have to do, you have to copy that link, and then you have to upload it in the classroom of the course. Okay, so in this way you have to submit your project assignments, and the quiz assignments will be given in the form of Google form in your Google Classroom. There you have to simply submit as a quiz. Okay, thank you.